In this video, we're going to go over Avogadros law, molar volume, and volume-mole relationship. So Avogadros law, it relates the moles of gas to volume. It states that moles of gas, or N, is directly proportional to the volume of the gas at constant temperature and pressure. So as the moles of gas increase, the volume increases. The equation for this is the initial volume divided by the initial number of moles is equal to the final volume divided by the final number of moles. When helium is added to a balloon, the number of helium atoms in the balloon increases, so the volume of the balloon increases. When you blow up a balloon, you're blowing in air molecules every time you exhale into the balloon. The more moles of air you're pushing into the balloon, the larger the volume of the balloon, the bigger the balloon is getting. So to practice, a child with asthma has a lung volume of 3.5 liters containing 0.50 moles of air when he inhales. After he exhales, the amount of air in his lung decreases to 0.15 moles. What's the volume of air in his lungs after he exhales? So we're going to use our Avogadros law equation. The initial volume divided by the initial moles is equal to the final volume divided by the final moles. Our initial volume was 3.5 liters. Our initial moles, 0.50 moles. Our final volume is what we're finding. And our final moles was 0.15 moles. So I'm going to plug those numbers into my equation. So 3.5 liters over 0.50 moles is equal to our final volume over 0.15 moles. I'm going to cross multiply and then divide, and my final volume is 1.0 liters. Molar volume. Standard temperature and volume, also known as STP, is known as 0 degrees Celsius in 1 atmosphere, or 273.15 Kelvin in 1 atmosphere. Therefore, the molar volume of a gas at standard temperature and pressure is equal to 22.4 liters. So 1 mole of a gas is equal to 22.4 liters at STP. This does not depend on the identity nor the molar mass of the gas, only the number of moles. So 1 mole of carbon dioxide, 1 mole of oxygen, 1 mole of helium all have the same volume at standard temperature and pressure. So how many moles of xenon occupy 34.9 liters at standard temperature and pressure? We want to know how many moles of xenon are equal to 34.9 liters. At standard temperature and pressure, we know that 1 mole is equal to 22.4 liters. So 22.4 liters is equal to 1 mole. We multiply on top, divide by the bottom. Our liters cancel out. We're left with moles. This is 1.56 moles of xenon. There's 1.56 moles of xenon in 34.9 liters at STP. You can only use that conversion at standard temperature and pressure. So density of a gas at standard temperature and pressure. For a gas at STP, the density is the molar mass of the gas divided by the molar volume. So the density of gas is proportional to its molar mass, since the molar volume of a gas is the same for all gases at STP. So for example, the density of helium. The helium, the molecular mass or the molar mass of helium is 4 grams per mole. You divide it by the molar volume. The molar volume is the same for all gases at STP. And then you divide and you get 0.179 grams per liter. The density of air at STP is 1.29 grams per liter. Helium is 0.179 grams per liter, which is much less than 1.29, and that tells us why helium floats in air, because it's much less dense. So practice, what's the density of carbon dioxide at STP? And will carbon dioxide sink or float in air? So the density of carbon dioxide is going to equal molar mass divided by molar volume. So molar mass is 44.01 grams per mole divided by the molar volume, which is always 22.4 liters per mole at STP. Divide by that, and it gives you 1.96 grams per liter. The density of air is 1.29 grams per liter. So the density of carbon dioxide is greater than the density of air, therefore it will sink in air. So volume and the moles of gas are directly proportional when temperature and pressure are constant, according to Avogadros' law. 1 mole of any gas at 0 degrees Celsius, 1 atmosphere, occupies a volume of 22.4 liters, known as the molar volume of a gas. And 0 degrees Celsius in 1 atmosphere is known as the standard temperature and pressure, or STP. The density of a gas is proportional to its molar mass. Gases with a molar mass less than air float in air.